inverse of a matrix simultaneous equations. All right. So here, example, solve the following pair of simultaneous equations using the matrix inverse method. So you can solve simultaneous equation using elimination or substitution or graph. You can also use the matrix method. Now, before we do this, we examine certain statements. Suppose you have a pair of simultaneous equation. You have ax plus by equal answer, call it n1, and cx plus dy equal n2, whatever number that is. If you put these in matrix form, so you have a, b, c, d. A, b, c, d are numbers times x, y. X and y going to be the answers. Alright? Equal the numbers. Number 1, number 2. So, these are what you have. Notice, if you multiply a times x plus b times y equal n1, you get the top equation, ax plus by equal n1. Notice that? If you multiply these two, cx plus dy equal n2. Cx plus dy equal n2. Alright? Now, the thing is, if you transpose this and make the answer x, y become the subject of the formula, what you're going to have is n1, n2 divided by a, b, c, d. You see that? Now, the thing is, with numbers, that can work. If you say a number, n over m, these are the same thing as n times 1 over m. Same as 1 over m times n. So, when you divide by a number, it's the same as multiplying by 1 over that number. Example, you have 5 over 6. It's the same as 5 times 1 over 6. It's the same as 1 over 6 times 5, right? Now, this means 5 times the inverse of 6. So this now, by the same argument, will be n1, n2 times the inverse of a, b, c, d. Now the thing is, the inverse of a, b, c, d will be a 2 by 2 matrix, and you can have 2 by 1 matrix times a 2 by 2 matrix. So put the inverse first. So a, b, c, d inverse times, then you have your n1, n2. So now you can multiply them and say a times n1 plus whatever that will be times this times n2. You can multiply these, this by this, one times this by this. 2 by 2 and then 2 by 1 on the right. You can multiply those, but you cannot multiply 2 by 1 on the left times 2 by 2 on the right. So basically, what you have is that xy, the matrix xy, going to be equal to a, b, c, d inverse times n1, n2. So you see that? Now, we can apply to this. If we just erase, or not necessarily erase, rewrite this. 2x plus 6y equals 36. So you have 2x plus 6y equals 36. What the other one say? 7x minus 4y equal 1. So you have 7x minus 4y equals 1. So 7x minus 4y equal 1. Now, rewrite them in matrix form. We have 2, 6, 7, 4, no, negative 4 times xy equal. So you have 36, 1. Those are the three matrices you have. See that? And then the answer xy going to be what? Xy going to be equal to 2, 6, 7, negative 4 inverse times the 36, 1. So you see that? So that means you're going to need to find the inverse of 2, 6, 7, negative 4. Now how you find the inverse again? ABCD inverse is 1 over AD minus BC times interchange A and D, change the sign of B and C. So you're going to apply that to this now. So what you're going to have is the 2 and the negative 4. They're going to switch places. Negative 4 come up here, so 2 go down here. So change the sign of 6 and 7. And it's 1 over AD. 2 by negative 4, negative 8. Minus BC, 6, 7, 42. Right? And you multiply that by 36, 1. You see that? So that's going to be 1 over negative 42 minus 8, that's what, negative 50 times negative 4, negative 6, negative 7, 2. Multiply by 36, 1. So you see that? Alright. So, continuing down here. This should be, I could have continued at the top. So, negative 1 over 50. Alright, so negative 1 over 50 times what we have again. Negative 4, negative 6, negative 7, 2. Negative 4, negative 6, negative 7, 2 times time what? 36, 1 times 36, 1. Alright, so this would be, when you multiply them out, negative 4 over 50. No, positive, because you're going to have negative 150th times negative 4. So 4 over 50. Then positive 6 over 50. Then 7 over 50. And then negative 2 over 50. And multiply by 36, 1. So, what that give you now? 4 over 50 by 36. So you have 4 over 50 times 36 plus 6 over 50 times 1 up top. And then 7 over 50 by 36 plus negative 2 over 50. We can just write the negative from minus 2 over 50 times 1. Alright, so what that going to give you now? Equal. So 4 over 50 by 36, that's our 2 into 4 goes 2 times 2 into 50, 25 times 36. So 36 2. Oh, make we just keep it as over 50. Keep the things as over 50. Because it's going to be easier to work out the fractions that way. Right? So 6 by 4 by 36 I mean. 4 6 24. Bring down the 4, carry 2. 4 3 is 12, 13, 14. 144 over 50 plus 6 over 50. Alright. And then what you have is 7 times 36, how much? 7 6 is 42. Bring down the 2, carry 4. 7 3 is 21. 22, 23, 24, 25. 252 over 50 minus 2 over 50. You could use calculator, but just sometimes you must practice your skill using only your head with pencil and paper. Alright, 144 plus 6 is how much? 150. 150 over 50. 252 minus 2 give you 250. 250 over 50. Oh, so you see what happened now? 150 over 50, how much? 3. 250 over 50. 5, 5, 25 is 5. So it's 3, 5. So you end up as 3, 5. So therefore, this xy, the xy that we have up there, the matrix xy equal 3, 5. So therefore, x equal 3, x equal 3 and y equal 5. So there we have the answer. You can test it too. X equal 3, y equal 5, just to make sure everything alright. X equal 3, 2 by 3 plus 6 by 5, 2, 3 is 6 and 6, 5, 30, 36. Alright, the first equation, alright. 7 by 3 minus 4 by 5, that's a 21 minus 4, 5, 20 equal 1. Good. So, we see x equal 3, y equal 5. So we get the answer.